Good morning, children. Today you will be studying the rest of this second half of this chapter, force and pressure. Okay. The other day you had studied till this numericals, and we did practice these numericals during the Zoom class. Now today you have to start from here and complete the chapter. Okay. So examples of pressure from daily life. So in this two kinds of, so this comes in reasoning questions, and then two kinds of applications will come. One is, pressure is force upon area. So what are the two factors affecting pressure? We said pressure is directly proportional to force. That means if force increases, pressure increases. If force decreases, pressure decreases. Second, pressure is inversely proportional to area of cross section. That means if area increases, pressure will decrease, and if area decreases, pressure will increase. Now, this is what is used in all these applications. So, in some cases like knives, and then thumbnails and all, and pencil, high heeled shoes. Okay, in all this area is less. Okay, area of contact. Knives, the part is very thin, very sharp. Nails, the part that goes inside the wall, is very sharp. So in these three cases, area is decreased. So what happens? Pressure is increased. Okay, because they are made narrow or thin, area is decreased, and because of that, pressure is increased. So easily, if it is knife, it can cut vegetables or anything easily. Nails, it can penetrate inside a wall easily. High heel shoes, because of this high pressure, it is very difficult to walk with a high heel shoe. A person can easily get imbalanced and trip down. Okay, so this is one kind of, some kind of, so you will have, and then the other one, like bags with broad straps. Okay, broad strapped bags. Then you have caterpillar wheel of army, tankers, then pillars of bridges. Now, these all come under another type. In all these things, area of contact is increased. Area of contact is increased. So, what is going to happen to pressure? Pressure will be decreased. Pressure will be decreased. And because of that, if you're talking about bag, you will say it reduces pressure on your hands or on the shoulders. If you talk about caterpillar wheel, you will say it reduces pressure on the ground, hence wheels of army tank do not sink into the ground. Then if it is pillars of bridges, then again it will reduce pressure on the ground. And so like this, so you'll have two types of um, examples. One is in which area is decreased, another one in which area of contact is increased. So as I remember one other video I told you, so 3 points you will write. First is about area decrease or increase, then about pressure, and then the third one, how it helps you. Because of that, what happens? As a result, cutting action is smooth and fast. As a result, they penetrate easily into the surface. As a result, the pressure on your hand or shoulder is less. Okay. As a result, when it is easy to carry from one place to another. Here, as a result, it is difficult to walk with a high heel sandals or shoes. Okay, so you need to write that also, what happens because of that. Okay, there are two examples here also. Steel rails of railway track are fixed over, they increase the area and decrease the pressure of the train on the ground. Coolies wear turbans on their heads the turbines help them to increase the area of contact, which reduce the pressure of the load on their heads. Okay, so you can expect one question to come from any of these examples can come. Okay, but remember you have to write all the points clearly. Okay, the next topic will be liquid pressure. Pressure exerted by liquid or liquid pressure, we can say. Now, the main difference between pressure exerted by solids and pressure exerted by liquids is solids exert pressure only at the base. Okay, so if this is a solid, I keep it on my hand, it can exert pressure only in my hand, only at the base. Okay, the part which is touching my hand, it can exert pressure only there, that is the area of contact. Okay, whereas in case of liquids, it can exert pressure at the base and also at the sides. Why is it so? Because liquids take the shape of the container, they don't have a shape, it's by themselves, so you need always a container to put, and they, because of this weight, they exert a pressure on the base. Also, because they are moving constantly, they'll exert a pressure on the sides. So this pressure at the sides is called a lateral pressure. Okay, a liquid contained in a vessel exerts thrust at all points below its free surface and thus exerts a liquid pressure. Then we have a new term called lateral pressure. This pressure exerted at the sides is given a special name called lateral pressure. So what is lateral pressure, or define lateral pressure can be a question. If you want, you can write it short like this: pressure exerted by a liquid on the sides of the container. Lateral pressure is the pressure exerted by a liquid on the sides of the container. Or if you want, you can write this. This is in a more detailed manner. Okay, then there are 5 properties of liquid pressure. Now, as I told you, you have to memorize it. Property 1, higher the density of liquid, higher will be the pressure. Property 2, as the depth of the liquid increases, or pressure at a point inside a liquid increases with increase in depth. That means if you take suppose a beaker having water, if you see the pressure here, okay, take this as it's 1 meter below the top surface. Okay, this is height h1 and another height you take h2, and this height is 2 meter. So pressure is exerted on this also and pressure is exerted on this also. Now which pressure will be more? Pressure on this. Why? Because more height, 2 meter of water will be exerting a pressure here, whereas at this height only this 1 meter, the water present in this area of 1 meter, this length of 1 meter will exert pressure. Okay, so that is what is the meaning of pressure increases with increase in depth from the free surface. This is called depth from free surface. So as the depth increases, pressure also increases. Then comes the third property. Liquid pressure remains the same in all directions at a given depth. Okay. Then this is one application of lateral pressure. Okay, lateral pressure. Water stored in a dam. Okay, so the walls of the dam are generally not parallel. They will be broader at the base. Why? So water will be standing here. Okay, and the water will be exerting more pressure. As the depth increases, water exerts more pressure. So these regions are under a high pressure from water. So if they are not broad enough, they might break down. They might crumble. Okay, that's the reason why walls are made much more thicker at the base. It is done so that pressure of stored water is maximum. Okay, pressure is more here. When compared to here, pressure is more here. So to withstand that high pressure, it is made broader. Okay, then liquid seeks its own level. Then the fifth property, liquid pressure at a point does not depend on the shape and size of the container. Okay, even if you study till this, it's fine. It does not depend on shape and size of the container. Next important thing is, what is the formula for pressure exerted by a liquid column? What will be your answer? P is equal to HDG. Please don't stop here. You have to write this also. Where P is the pressure exerted by liquid, H is the height of liquid column, D is the density of liquid, and G is acceleration due to gravity. Then we also have consequences of liquid pressure, which also can come in reasoning questions. Okay, so deep sea divers wear a special type of suit, all these things. Okay, so now deep sea fishes, if you bring them to the top, okay, see, fishes which normally live in deep sea, their blood pressure will be high. Their blood pressure will be high because the pressure from outside is also high, so their blood pressure, usually their blood pressure will be high. Now such fishes, if they come to the top, what happens? Their inside pressure will be always high, blood pressure will be the same, but outside pressure decreases because the height is less. Here it was at this height, this much water will exert a pressure, whereas when it comes to the top, only this much water is going to exert a pressure. So inside pressure is greater than outside pressure. So what will happen? It will burst. It will burst. You understand? Inside pressure is so high, the blood pressure is so high, it can just burst and blood can come out. The other hand, the other possibility is, now sea divers or human beings, our blood has a pressure because we live in the we live on the surface of earth, we don't live inside water, right? So our blood pressure is equal to the pressure that is outside on the surface of earth. Now if a sea diver goes inside, what happens? Outside pressure will be high, but his blood pressure will be low. Okay, so outside pressure will be greater than inside pressure. So what will happen? That will crush his body. Are you able to see the difference, children? Anything that was inside a fish, that is usually inside, if it comes up, what will happen? It will burst. And a human being who is normally on the surface of earth, when he comes, he's a deep sea diver, he comes sometimes into deep sea, then his body might get crushed because outside pressure is more. Are you able to see this difference? Please study it clearly. Then we have pressure in gases, and in that specifically atmospheric pressure. Okay, our earth is surrounded by air and the air exerts a pressure. And then why we don't experience that pressure? Because our blood is also exerting a pressure, and that balances atmospheric pressure. And there is an important thing, device used to measure atmospheric pressure, that is barometer. And what principle or how does it measure? In terms of height of mercury column. And standard value 76 centimeter. Then value of atmospheric pressure 10 power 5 Pascal. Then these all can come in reasoning questions. Okay, this I have told already clearly how to write. So study everything clearly. Okay, children. So yeah, that's all. With this, the chapter is over. As you know, you will have a test of this chapter, whole chapter test, on Friday during Zoom class. Okay, so study thoroughly. So tomorrow you finish this half during the daytime, and by evening I'll send you a worksheet for revision. Okay, you can answer that and send it back to me. That's just for your practice. Just for your practice. Okay, and on Thursday you can revise the whole chapter, and Friday you will have the test. Is it clear, children? Okay, so study thoroughly, and in this test all of you should score more marks than your previous test. Remember that. Okay, thank you so much.